Good morning to all. This is in continuation of the previous problems on Fourier series. Now just we are discussing all possible wave formats that may be given in the examination. In this series, now we are going to solve some other kinds of Fourier series. Now just look at, we are taking a Fourier series of the format. Just look at, it is from 0 to t by 4. This is t by 2. This is 3 t by 4. This is t. Now, in this way, it will be like this. Now just look at, the waveform is like this. The waveform. Now we have to find the Fourier series for the given wave format, t and x of t. Students have to notice this process of wave format. Wave, the height, its value, amplitude, that equal to a. Now, wave, no wave, wave, no wave, wave, no wave. So now here the process is how the process is going on between wave and no wave. So now we have to consider the entire wave, no wave movement. For that purpose, the first we have to find the modeling of the given wave format. Now just look at, we have to make it from 0 to t by 4. Another condition is between t by 4 to t by 2. Two conditions. Between 0 to t by 4, the wave is reaching up to the amplitude a. Between t4 to t2, there is no wave. Value equal to 0. Got it? First mathematical modeling. So wave, no wave. Look at wave, no wave, wave, no wave. So we have to consider full period between 0 to t by 2. Wave, no wave. So here the full period t belongs to between 0 to t by 2. One more point. The wave, no wave format, these are to the right side and the left side of the y-axis. In this way, therefore, the wave is symmetric. The wave is symmetric. If any wave is symmetric, the signal is symmetric. Whenever it is symmetric about y-axis, the signal is an even signal. The signal is an even signal. Even signal. Whenever it is even signal, for Fourier series, Bn equal to 0. No need to calculate Bn. Therefore, the Fourier series of x of t, that will be half a naught plus summation n equal to 1 to infinity an cos n omega naught t. So now here, what is a naught? A naught equal to 1 by total width t by 2, total width integral. Now we have to find 0 to 2 by 4, t by 4 to t to 2. These two we have to consider. But the second part equal to 0, so no need to write the second part. So directly write the first part, 0 to t by 4 of x of t. X of t means a into dt. So this is equal to a is constant. This is 2 by t. A, for this integral we get small t, substituting t by 4 value. Therefore, its value equal to a by 2. This is first value. tt cancel a by 2. Now next we have to find an. an equal to 1 by t by 2, that means 2 by t, between 0 to the interval t by 4, x of t means a into cos n omega naught t dt. Here a is constant. So you can write 2a by t into, for cos, this is sin n omega naught t by the constant n omega naught between the limits 0 to t by 4. So n omega naught is also constant. Therefore, we will get 2a by t constant 1 by n omega naught into substituting t by 4 in place of sine. So that equal to sine n omega naught into t by 4 minus sine 0 equal to 0. Sine 0 equal to 0. Now put what is value? Omega naught equal to 2 pi by t. So this implies its value equal to 2a by t into 1 by t by 2n pi into sine n omega naught 2 pi by t into t by 4. Now t cancel, 2 cancel. This implies its value equal to a by n pi into t cancel. This implies sine n pi by 2. Sine n pi by 2. Look at the values. So this is the value of an. Now we got a naught into in 1 and an in 2. Now substituting, put 1 and 2 in the main. What is that? A. This implies the Fourier series of the function x of t equal to half a naught. Already a by 2. Half means it will become a by 4 plus summation n equal to 1 to infinity. 1 to infinity. Its formula how much? an. An value is how much? A by n pi into sine n pi by 2 into its value remaining part cos n omega naught t. This implies a by 4. The series is for n equal to 1 to infinity. Therefore, the series is n to infinity. So what are constants? A by pi are constants. So remaining one are within the, after the summation infinity. This is equal to 1 by n into sine n pi by 2 into cos n omega naught t. Cos n omega naught t. Now just look at, this is the Fourier series of the given wave format. Very important point. Students have to notice it. Whenever it is given in the wavelet format, students have to model. Model means find the signal, mathematical modeling of the signal wave format. It is a mathematical modeling. Two parts are there, wave, no wave, wave, no wave. So you have to take both into consideration, wave with no wave. In the wave, it reaches the highest point equal to A. In the no wave means 0. So unnecessarily no need to calculate the second part of 0. It is already 0. That's why here just we calculated this one. One more point. Whenever a wave is surrounding the y-axis about the right hand side and about the left hand side, in that way the wave is said to be symmetric about the y-axis. When it is symmetric about the y-axis, whenever it is symmetric about the x-axis, y-axis, the wave is said to be even. Whenever it is even, so no need to calculate Bn. So the Fourier series for the function equal to half a naught summation 1 to infinity a n cos n omega. So here how to calculate a naught? This is a naught equal to 1 by t. Here t means what? Full length, t by 2. A is constant. We got the a value. Next we got, substituting this one, a n value. Here one more point, cos n pi, sin n pi by 2 we got, because sin pi by 2, sin pi by 2 value how much? equal to 1. When n equal to 1. Now, when sine 2 times pi by 2, that means what? Sine pi. Sine pi equal to 0. So now here we have to consider only odd values. So here n is odd, where n equal to 1, 3, 5, 7, like this. So now just we have to make like that when n is odd. Otherwise, the summation also you can write like that. The summation, in the summation, without writing this sentence, in the summation you can write summation n equal to 1, 3, 5, etc. to infinity. Also here you can make it. Otherwise, you can write where n equal to 1, 3, 5, 7 odd. That means what? This series, the Fourier series of this wave function will be responding for odd values of n only. For odd values of n only. Odd values of n only. So this is the Fourier series format of the given waveform. Thank you.